In this video, I am going to start a new chapter of physics, that is reflection of light. Reflection of light. This chapter is important, or it has been given from standard 7, 8, 9, 10, 12. So this is very important topic. Its conceptual parts, its numerical part, its diagrammatic part, all are important. So if a beam of light passes through a homogeneous medium, then it will go straight. That means its path will be straight line. But if a beam of light passes through a refracting surface, or we can say a transparent medium or transparent surface, then here we will see some other properties. So the first word is reflection. Reflection is the returning or bouncing of light in a same medium It is returning or bouncing of light in a same medium when it strikes a surface. Very important. So, when light returns back in the same direction after striking a hard surface, or surface is called reflection of light. So suppose we have taken, this is an opaque surface. There are three types of mediums are there, or surfaces are there: transparent, translucent and opaque. So if light passes through transparent medium, then some part of light will bounce back in the same medium, and the remaining part of the light is absorbed by this surface. A very important part. For opaque, some light will return back in the same medium, and remaining part of the light is absorbed by the surface. A very important point for the opaque surface. The remaining part will be absorbed. But the same light is passed through a transparent medium or transparent surface. Transparent surface, here this is the incident ray, this is the refracted ray. Some part will be absorbed. So here three process we will see, three part we will see. First we will see reflection, second is absorption of the light, and the third part is the transmission of light in the second medium. Transmission of light in different direction. So this is a very important process, that reflection is a process in which light will return in the same medium after striking a hard surface. But apart from reflection, some part of light or partly will be absorbed, partly light will be absorbed and partly light will be transmitted in the another medium. Second thing, that there are two types of body. First is the luminous body, like star, like sun. So luminous body has their own light. They produce light themselves, so they are visible, they are seen to us. But if we take non-luminous body, non-luminous objects, that objects which do not emit light, so they are visible only if light falls on it, and after reflection that light falls on our eye. That means here, for visibility of non-luminous body, first light should strike the surface. Striking of light, where? So non-luminous body or non-luminous object, then bouncing, light must bounce, and that bounce light falls on our eye, light falls on the eye. Then only we will be able to see non-luminous body. For example, all the objects like plants, like any materials that are present in the atmosphere that cannot emit their own light will keep in a category of non-luminous body. And for non-luminous body, reflection is important part. Unless there is a reflection, unless light will fall, reflected light falls on our eye, we cannot see it, we cannot feel it. This is the point of light. Second thing that we have to study, that surfaces, types of surfaces, because reflecting tendency surfaces, reflecting capacity or reflecting tendency depends upon the surfaces also, which type of surfaces we have. If we have transparent polished surface, if we have polished surface, silvered surface, then as much light will fall, that much light will return back in the same medium. For example, plain glass or plain mirror. A plain mirror is made up of few millimeter thick glass plate. It has two surfaces. Its front surface is highly polished. This is the reflecting surface. And its second surface is silvered. And for silvering, we use either silver metal or we use mercury. After that, this will be covered, this silvered surface is covered with opaque body, so that it could be that silver surface should be protected. It could be protected. So this is the design of a plain mirror. A plain mirror, we see this is the polished surface. This is where the reflection of light takes place. There are two types of reflection. So the next part that we need to study is kind of reflection. First is the regular reflection, and second is the irregular reflection. Very important points. So these kinds of reflection based on the kinds of surfaces we have selected. If we have taken smooth surfaces, polished surfaces, then regular reflection takes place. Whereas if we take rough surfaces like wall, like earth crust, here irregular reflection takes place. So there are some differences that is used to distinguish regular or irregular reflection. This is very important concept. So the light is an important phenomenon, and we use from in ICSE syllabus start from standard 7 only. Those who are in standard 7, they are observing light, what is light, the effect of light. Standard 8 also, standard 9 also, even in standard 10 also. In 10 is a numericals part, 9, 10 is a numericals part, and 12th we go in detail. The detail part we study in standard 12. So this is very important part. You have to focus this. You have to understand this topic. This is a so we have to discuss kinds of refraction. So here regular and irregular. This takes place from smooth surfaces, whereas this takes place from rough surfaces. Here, parallel light falls on the surface and reflected light will also be parallel to each other. Very important point. This we can explain using a diagram. Suppose this is a smooth surfaces. Suppose the light will strike here. After striking, it will bounce back. This is another ray. This will also bounce back. Another thirdmost ray. This is also bounce back. So here the incident light, these are incident light, and these are reflected light. So such type of phenomenon takes place in irregular reflection. But when we are going to use irregular, here we use rough surfaces. So the light strikes, it will not bounce properly, and the light will not be parallel to each other. This is a irregular reflection. So due to irregular reflection, because here direction is fixed, it goes in the same direction. This parallel light, it same direction. All parallel light, all reflected light will go in the same direction, and we will see it. Here reflected light will go in different direction. You can say that reflected light in different direction. And this is the irregular reflection. This is irregular reflection. that when it falls on non-luminous body, we will be able to see that body. We will be able to identify that body. So this is the second information related with the kinds of reflection. Third is the some terms or topics related with reflection. What are the different steps? What are the different terms that we are going to use related with reflection? This is the perpendicular drawn on the surface. So this is known as normal. A ray will strike here. This is called incident ray. And this is the point where ray strikes. So we can say point of incident. This light will reflected back, bounce back. This is reflected light. This is the angle. Mind it, angle between incident ray and normal is called angle of incidence. Whereas angle between reflected ray and normal is called angle of reflection. So here we have got different points. What is incident ray? This is the light which strike this is transparent surface. So light which strike the surfaces, that ray is called incident ray. The light which return back in the same direction, that is same medium, this is called reflected ray. Point where it strike, the point of the surfaces over where light strikes is called incident. Point of incidence, and this is point of reflection. The perpendicular drawn on the transparent surface is called normal. The angle between incident ray and normal is called angle of incidence, and the angle between reflected ray and normal is called angle of reflection. So here we get laws of reflection. What are the important laws that we are using to show the process? This law is very, very important to draw the diagram, because the light part is, this chapter is full of ray diagram. We have to use ray diagram. So for this we have to understand laws of reflection. We have to understand, we have to know what are the important laws of reflection. So the first law is that incident ray, that is angle of incidence, is equal to angle of reflection. Suppose if light strike the surface with an angle of 30 degree, then this will be reflected with also angle of 30 degree. So the angle between incident ray and reflected ray will be 30 plus 30, that is 60 degree. So this is the angle of incidence is equal to angle of reflection. Second is the incident ray, normal, reflected ray, all lie on the same surface. Very, very important. Very, very. So these are the two information that we have from the points related with laws of reflection. So suppose we can explain this using different points. Suppose here this is A, this is O. So here AO is the incident light. This is AO is the incident ray. Suppose this diagram, this is B, this is N. OB is the reflected ray, and ON is the, NO is the normal. So this is the information that we have from the different part. Next is the image. When the process of reflection, when the process of reflection takes place, then the different types of images that we find, there are two types of image that is very common and very famous. First is the real image and second is the virtual image. There are two types of image we know. First is the real and second is the virtual. So real image and virtual image. This is the image that can be obtained on screen. So you can say that it can be obtained on screen. Here it cannot. Can't. The image that we see in the mirror is the virtual image. This is the virtual image. Second, it actually meet or it appears to meet. The ray actually meet. And here it appears to meet. So we can see the reflected light. If it is produced, then we will feel that the image is virtual image. We can say that this image, real image, always be inverted. Very important. Whereas virtual image always be erect. The image we see in the mirror is the erect image. So this is the virtual image. Whereas the image that we see inverted, that is the real image. So these are the information we have got. After that, there is one term that is given in the book. It is very important. That is lateral inversion. Very important. That is interchange of left and right of the image of the given object in a plane mirror is called lateral inversion. If the left is appear right in the image of an object, for example, suppose this is a plane mirror. If we see, then it appears like this. If we write B, it appears like this. If we write L, it appears like this. So this is called lateral inversion. The left part appears to right part appears to left. This is called lateral inversion. So with the help of this, here the next part is the characteristic of image by a plane mirror. What are the different characteristics of image by a plane mirror? So a plane mirror always gives, first is the virtual image. This is the characteristic of the plane mirror. First information, it gives virtual image. Second information, the image must be erect. Very important, it must be erect. Third is, in plane mirror we get image that is same size of the object. So size and distance of image will be same to the size and distance of the object from the mirror. Size and distance of image will be same to object. And the last is laterally inverted. Here we get laterally inverted. That is lateral inversion takes place. Laterally inversion is going to be visible here. Laterally inversion, or you can say lateral inversion. So these are the information that we have got from the reflection of light. That what is reflection of light, then the different types of the different information, that is incident ray, that is reflected ray, that is normal, then different types of surfaces, rough surfaces, smooth surfaces, kinds of reflection, regular reflection and irregular reflection, then real image and virtual image, then it is lateral inversion and the laws of reflection. After that, there are some questions given. This question is very important, and I think you should know this question because you will get such type of question in the exam. So next is the question that is very important related to the plane mirror. Question is, an object is at a distance of 20 centimeter in front of a plane mirror. Suppose this is a plane mirror. And an object is kept at a distance of 25 centimeter, or it is, yes, 25 centimeter from a plane mirror. The mirror is shifted 5 centimeter away from the object. This is the initial position of the mirror. After that, it shifted 5 centimeter away from the, this is 5 centimeter here. This is 5 centimeter. Find the new distance between the object and image and the distance between two positions of the image. So the first question is, first question, distance, new distance. First question, new distance between object and image. And the second is the distance between two positions of the image. The distance between two positions of image. Very important information. Suppose in the beginning this is the object. If it is 25 centimeter, then the first image also 25 centimeter from the mirror. This is the first image. Because I have already said that in plane mirror, the image distance from the mirror must be equal to object distance from the mirror. If it is 25 centimeter, this will be also 25 centimeter. When this is shifted, then the new image distance from the mirror is 30 centimeter. So here the final image also will be shifted 5 centimeter. This is the final image. This is the initial image, and this is the final image. So there is a question, new distance between object and image. So after shifting, object distance is 30 and image distance is also 30. So the distance between object and image is 60. Very, very important. This is final new distance between object and mirror. This is the mirror. After shifting, this is the mirror. So the distance, new distance is 30 centimeter between object and mirror. The final distance also be 30 centimeter. This is 5, 25. This 5 I have shifted. So this is 30 centimeter between this. This should be 30 centimeter. So 30 and 30 will be 60. And the distance between two positions of the image. So we can say that first position of image was 25 centimeter. This is, and new position of image is 30 centimeter. So the distance between two position of image, this is so it is the new distance and initial distance of image from the object. So here it is given from the object. The distance between two positions of image from the object. So the first position of image from the object is 25, it is 50. And the new position of the image from the object is 60. So distance, this is the distance between two positions. So distance is equal to 60 minus 50. It is 10 centimeter. So this is the information that is related with reflection of light and using plane mirror. Plane mirror, image distance from the mirror and object distance from the mirror always be equal. If we move mirror from the object, as much distance we move, that much distance image will also move from the mirror. This is an important information related with the mirror. Its second type is images formed by a pair of mirror. A very, very important information. If we take two inclined mirror, then how many images are produced? What is the formula of that? This is very, very important. So, images between two inclined mirror. So, there is a formula that suppose n is the number of images. So, this is 360 degree by theta, where theta is the angle between the two mirrors. Now, if the value of n is odd, very, very important, if the value of n is odd, then this is equal to the number of image when the object is placed asymmetrically. For asymmetrically object between two plane mirror, its image number, its number of image always be equal to n if it is odd number. When we are going to take symmetrical body, for symmetrical body or symmetrical object, n minus 1, if n is even, mind it, if n is even, then number of images will be n minus 1 for symmetrical object. That is very, very important information, that what is the formula to find number of images between two inclined mirror. This will be 360 by theta, and if n is odd number, then this is equal to the number of image for asymmetrical body. If n is the even number, then we will use n minus 1 for the symmetrical body. Second information, that if the two mirrors are parallel to each other, a very very important information. Two plane mirrors are parallel to each other. Then here theta is equal to 0 degree. So n is equal to 360 by 0, that is infinite. Infinite numbers of images are produced here. That type of mirror we use in the barber shop. And if the angle, second point, if theta is 90 degree, that is two plane mirror are at an angle of 90 degree, then its n will be 4, 360 by 90. So number of images will be n minus 1. This is n minus 1, that is 3. So these are the information that is related with a plane mirror. What type of image formed by plane mirror? Plane mirror gives virtual image, erect image, same size of the object, and lateral inversion. It will show lateral inversion. Then how will we find distance of the image, distance of the object from the mirror? If the mirror is shifted from the object, then image will also be shifted. So this is a way. Then if we are going to use two plane mirror with some angle, then how many images are produced? This is the formula 360 by theta. If theta n is odd, then this is okay for asymmetrical body. And if n is even, then n minus 1 is the number of image for the symmetrical body. And if the two mirrors are parallel to each other, here infinite numbers of images are produced. And if the two images are at an angle of 90 degree, in this case number of image will be n minus 1. Because n is 4, it is a even number, so n minus 1 image will be produced. So these are the information that we have used from the plane mirror. Next we have to study the spherical mirror. Very very important information. Actually we study spherical mirror in the standard 8 in detail. The types of spherical mirror and the ray diagram we study in standard 8, 9, 10, and its numerical part we study in standard 9, 10 and 12. So spherical mirror. So here mirrors are three types. First is the plane mirror, second is the spherical mirror. A spherical mirror further classified into two parts that I am going to explain, and the information related with the spherical mirror. So, types of spherical mirror. Suppose this is a sphere. Then in case of a sphere, we are doing silvering in two different surfaces. The first is silvering on the bulging surfaces, outer cover surfaces. This is called concave mirror. In the second case, silvering is done hollow part. This is the hollow part. This is called convex mirror. So light will strike here. This is the light, incident light part. And here light will strike this part, striking part of light. So these are the information about types of spherical mirror. This is very important. There are two types of mirror we are going to use. First is the concave mirror. This is the supposed part. This is the hollow part. If this hollow part is okay and silvering is on this outer part, this is concave mirror. And if silvering is inside and attacking is outside, this is the convex part. So these are the information. Now here the first part we have to focus. The first information we have to focus, that is center of curvature. The first part is center of curvature. So we can say that the center of curvature is the same part of a mirror, is the center of a sphere, and mirror is its part. This is called its center of curvature. Second is the radius of curvature. This is the radius. So from here to here, this distance is radius. This is radius. Then third part is pole. This is the geometrical midpoint. This is called pole. Fourth point is aperture, the part, and the line joining this principal axis. This is called principal axis. Pole to center of curvature, straight line. This is called principal axis. Very important point. Please see nicely that this is a hollow part or curved part of a mirror. If we extend it, it will take a part of a sphere. It will take a shape of sphere, and center of sphere and the center of mirror will common. This is called center of curvature. This is the midpoint of the geometrical midpoint of the mirror is called pole. The straight line joining center of curvature to pole is called principal axis. Next information is the very important information, reflection of light ray from a spherical mirror. We have studied reflection of light from a smooth surface, plane surface. How the process of reflection of light takes place from a curved surface. It will follow the same rule that we have done plane mirror, that is incident ray and reflected ray. Suppose this ray strikes, suppose a ray strikes to the point of a curved surfaces. Then from this point first we draw the normal. That is very important. First we draw normal. This is the angle of incident. The ray will reflected and the angle will be the same. This is angle of incidence, must be angle of reflection. For this surfaces, suppose this is the suppose ray strikes First we will make the normal, this normal. This is the angle of incidence. It will bounce back with some angle, that is angle of reflection. So in this way we can draw angle of incidence and angle of reflection in the same way as we have done for the plane mirror. Now focus of and focal length. A very important information, focus and focal length of a mirror. Suppose this is a mirror. Suppose this is a mirror. This is the center of curvature. This is the principal axis. Suppose a ray strikes here, here also. Then we will draw normal. The point where it strikes, from there we will draw normal. This is angle of incidence. Here also. This is C. Here also. This is the normal. And then ray will bounce back and cut the principal axis at a point. Here also. This is angle of incidence, this is angle of refraction, this is angle. This point is called focus of the mirror. And the distance between focus to pole is known as focal length. This is very important information. For convex we can also draw. Actually in convex the ray appears to meet. Here that ray actually meet. So this is a real image. This is a real image. Here the ray will appears to meet. After reflection, if we extend the ray, suppose a ray will strike here. Suppose a ray will strike here. This is the normal. This is the normal. We will extend it and it will reflected back here. It will stay down. This part. Stenotic is Actually, here I am showing the little bit. The ray will strike like this. Like this. And this, it will go like this. Here will extend. This is the point. I, this is R. So in this way, we can write focus of the mirror, and this focal length is equal to half of the radius of curvature. F is equal to R by 2. After that, we have to use the next point is convenient rays for construction of image by a diagram. This is very difficult, and this is very important. Very important. Convenient rays for the construction of image by ray diagram. Whenever we are going to draw ray diagram, some points we have to discuss, some points we have to focus. For example, the first information, a ray passing through center of curvature. First point, a ray passing through C, center of curvature. I am using here concave part because it is easy to design or draw concave part. If a ray will strike, passes through center of curvature, then it will return back, it will retrace its path. A very important information. The way it will go, it will bounce back in the same path. That's why it will retrace its path. Second, a ray parallel to the principal axis. This is, if a ray parallel to the principal axis, it passes through its focus. Suppose, if a ray parallel to the principal axis, then after bouncing back, it will cut a point. This point is called focus. This is very important. So a ray incident parallel to principal axis, after reflection from a spherical mirror, it appears to come or passes to be coming from focus. Here it is coming from focus. For concave coming, and for convex appears to come. Third point, a ray passing through focus. A very important point. If a ray passing through a focus, suppose this is the focus of a ray. This is center of curvature, so half part. If a ray passing through focus, then it will go and bounce parallel to the principal axis. It will go and bounce parallel to the principal axis. So, a ray either incident from the focus, after reflection from a spherical mirror, becomes parallel to the principal axis. And the last point is a very important, a ray incident at pole. If a ray incident at the pole, then suppose if a ray incident at the pole, here, suppose a ray incident at the pole, then this principal axis becomes normal, behaves as a normal. This is angle of incidence, and this will be come out, this is angle of refraction. So we have got the four information. First information, if a ray passes through center of curvature, it will retrace its path in the same opposite direction and the path will retrace. If a ray passes parallel to the principal axis, it will passes through focus, it is coming from focus or appears to come from focus. Third point, if a ray passes through focus, it becomes parallel to the principal axis. And the fourth point, if a ray passes through the pole, then here principal axis behave as a normal, it will return back and making some angle, that is angle of reflection. So this is the last point, that a ray incident at a pole of a spherical mirror, the reflected ray is at an angle of reflection equal to angle of incident with principal axis as the normal. Here this principal axis behave as a normal and this angle always be equal. So in this way we can get information. Once we have idea that if the ray is passing parallel, we can easily say the image will be at focus. If the ray passes through the focus, here the image will be at infinity because going parallel, so we can say infinity. If the ray is at the center of curvature, it will retrace path, so image will be also at center of curvature only. So these are the information, and here table is given in the book that you have to memorize, that position, size and nature of image formed by concave mirror and convex mirror. The only difference is that in concave mirror, the maximum images are real and inverted. Some images are virtual and erect, but maximums are real and inverted. Whereas in convex lens, maximum images are, we can say, virtual and erect. So this is the first point we have to memorize, that in concave we get real and inverted. There is one condition over there, the body will get virtual and upright image, erect image of a concave mirror between focus and pole. If the object is between focus and pole, then only here we will get virtual and upright. So such type of tables has been given in different book, whether you are using ICSE or CBSE, the information related with image. For example, if the object is at infinity, this is infinity, then image will be focused at focus. So this image must be diminished, this image must be erect and inverted. So we can say that at focus it is diminished, real and inverted. Second, if it is very far distance, then focal plane. If it is at the center of curvature, then image is also at the center of curvature because it retraces its path and at the same side of the object. If it is beyond the center of curvature and focus, then image will be magnified, real and inverted beyond center of curvature. If the object is at focus, here image will be at infinity, it will be magnified, and between focus and pole, here if the object is taken between focus and pole, suppose this is the focus and pole. So here we keep the object, the image will be virtual and erect. So this is the information of the ray diagram, that is for concave mirror. The same things we will use for the convex mirror, but for solving the numericals, mirror formula is 1 by b plus 1 by u is equal to 1 by f. Here b is the image distance from the mirror, u is the object distance from the mirror, f is the focal length of the mirror. So here some point we have to see, some important point we have to mark, that is going to be important. Some information we have to keep it in mind to solve the numericals, and some sign convention we have to use. What are the sign conventions that I am going to explain. So here, suppose this is a mirror. Here is the object we keep. So this is object distance In front of mirror, if object distance, you always be taken negative. A very important information. This part is negative, this part is positive. So object always be taken in front of the mirror, it will be negative. If image is before the mirror, then it will be negative. Or if image is after the mirror, that we see in convex, it will be positive. Focus of a concave mirror, focus for concave mirror, it is negative. Whereas focus of a convex mirror, it is positive. So using this sign convention, we can solve numericals based on that. And the magnification of the mirror, that whether it is bigger or smaller magnified, we use minus b by u, that is size of image or image length, size of image distance, or size of object or length of object. This is the information that we keep in our mind to solve the question. Then uses of spherical mirror. A spherical mirror, concave is used as a saving mirror, it is used as a reflector, it is used as a doctor's head mirror. Concave, big magnified image it gives, that's why we use as a saving mirror, as a reflector and as a doctor's head. Whereas convex mirror used as a reflector in a street lamp and as a rear view mirror. A driver use convex mirror to see the erect image of the object. That is very important. Unless the driver will see erect image, he cannot judge how to go, how to move. So this is the information. So there are some differences given between concave mirror and convex mirror. I just want to read. Concave mirror is made by silvering the bulging part and light strikes the hollow sphere. Whereas in convex mirror, silvering is inner surfaces or hollow surfaces and light attack the bulging surfaces. Concave mirror is also called converging mirror. Very important information because light meet at a point. So concave mirror is also, this is a very important information. Concave mirror is also called converging mirror because light converges at a point, whereas convex mirror is called diverging mirror. It is called diverging mirror because here light bulges out. Third, in concave mirror, image may be real or virtual also. Virtual I have explained between focus and pole, and the other images are, that is when object at focus, when object at center of curvature, when object at infinity. In all the cases we are getting real image and inverted image. Whereas convex image always virtual. There will be no real image in convex mirror. And concave gives diminished image also, same size also, magnified also. It gives magnified, it gives diminished. When object comes from infinity, it will be diminished. When object is at focus, it is magnified. And here, convex mirror is image always be diminished. So these are the information that we have got. One question I want to discuss that is very important. For example, the first question is, if the radius of curvature is 16 cm, find out focal length. If radius of curvature is 16 cm, then focal length is r by 2. So 16 by 2, it is 8 cm. Second question is that given an object is placed at a distance of 48 cm in front of a concave mirror of focal length 24 cm. I am just giving the information from the diagram. Suppose you have taken a concave mirror. And here object distance is 48 cm from the, and its focal length is given 24. So u will be minus 48. Focal length is concave is negative. So minus 24 centimeter. Find the position of image. You have to find V. So you just apply the formula 1 by V plus 1 by U is equal to 1 by F. So 1 by V is equal to 1 by F minus 1 by U. Put the sign convention or value with sign convention. Minus 24 minus 48. So it will be minus 24 and plus 1 by 48. Now you can solve this and get the value of image distance. Here, what will be the nature of image? Whether the image is negative or positive. If the image is negative, then it will be real and inverted. And if it is positive, it is virtual and erect image. So we can say that here, this is the information. This way, we can solve question based on light. Here, name the kind of mirror used to see a real and enlarged image. We have got the idea that convex always gives diminished image, but here enlarged image we get in a concave mirror. Virtual and enlarged image, again here concave mirror, because convex gives diminished image. Virtual and diminished, it is convex. Real and diminished image, it is concave. So in this way we can solve the question and the other parts related with the question. So I hope whatever information I have given from this topic is going to be useful to you, and you will get idea from the topic, and it will be easy to explain, understand the topic. So in the next video I will give question based on light and some other information I will give. Thank you.